All right. Wow, this is loud. So this is a terrible name. I don't know why I picked it. Usually I come up with random, like really opaque names because I don't really know what I'm going to talk about. But in this particular case, I had something really specific that I wanted to talk about, so I got really excited. But Dell SecureWorks kind of screwed me, and they put out a really nice blog post about August. Sorry? Did you raise your hand? Okay, I was just wondering if you are actually Dell SecureWorks, because I didn't know if they're actually here. Is anybody from SecureWorks here? No? All right, I can't make fun of them too much then. All right. Point being, they put out a great blog post about the Bitcoin hack that happened earlier this year, which I happened to notice at the same time, and I did some research on it as well. So that's primarily what this talk was going to be about. But since they kind of blew it and dropped everything around Black Hat, I decided to go through a more general understanding of my experience within like Bitcoin, Dogecoin communities, understanding the technology and the security ramifications of the decisions they've made and other strange coins have made in these environments. So I have to give you a little bit of background as to why and how I got into this, because I'm not normally a Dogecoin proponent kind of guy. But in this case, like, I actually became one. And it was odd how it happened. So a couple of very good friends of mine from Chicago decided one day that they were going to call me up because they were like, hey, we're closing these $500,000 deals with robotics companies, and they're starting to ask us about Bitcoin. And their comment was initially, why? Why would anybody in pneumatics ever care at all about Bitcoin? Let alone bringing up Dogecoin in an executive meeting in a pneumatics company is just bizarre. So they didn't know who to talk to about it. So they're like, all right, we'll ask Don. Why not, right? So they called me, and I really didn't have any answers for them at all. Like, I didn't know what to say. I just thought like, oh, you mean that cute little coin with the dog on it? Whatever the hell that is, I don't care. Call me back when I've actually had a chance to do some reading. So I figured, all right, we'll get this figured out. And we ended up wasting a lot of time on it. Because they said, hey, why don't we end up starting a business together just to see what it's like? So we ended up going from like a weird meeting to a weird phone call, just being like, screw it, let's just blow 50 grand on a warehouse for no reason. So we kind of got a little bit too deep, and we is this gonna move? All right. And then we ended up going up to northern Michigan on the border near Canada. So there's like the Upper Peninsula. It's freezing cold up there. And it's important to know where we were because it really gave us the ability to do whatever we wanted. We had a warehouse in northern Michigan that was an average of negative 20 degrees below zero. It was an average snowfall or an average snow accumulation of about 6 meters in snow on the side of the building. We had so much cold air and so much space that we just said, what the heck? It cost us about 110 USD to change the electrical infrastructure of the environment. And we built up a massive GPU mining operation in this warehouse just because we were like, oh, let's be curious about Dogecoin. That sounds fun. So the ability for us to actually build this was really important because the results are only based on the environment that we had. If we didn't have this environment, there is absolutely no way that I would have been able to give you any of the results that I found in this talk. It just wouldn't have been possible. But it was all because of the infrastructure we were able to build in northern Michigan. So the average power failure in this kind of area is really high because it's extremely rural, right? And we were running so much juice. We were averaging a power bill somewhere around the area of 2,000 USD per month. And of course, our revenues were exceeding that only slightly. But we ended up making a small amount of money per month. But if we're running about $2,000 worth of infrastructure, you can imagine how many GPUs were actually there. So what was exceptional about this place, and the only reason why we were able to succeed again is because of this environment. We had an airport directly across the street from this warehouse. and we were tied into the airport's electrical grid. So whenever the city went down, we didn't have to worry about it because we were on the airport's backup. So we had absolutely no problems with electricity the entire time we were there, except for the times that I electrocuted myself, but that's a completely different story. In fact, and I have to say this very quickly, we almost caused an explosion. So if you ever have one of these kinds of infrastructures in a remote place, be very, very careful, because it turns out when you're in an environment where the snow gets so deep that it's about 6 meters or higher, sometimes the caps in the homes and warehouses that you use end up getting a small film of ice just from the moisture that accumulates in the air during the day. And it will freeze over that piping infrastructure and disable sewer gas from escaping your home or office or whatever. I came back from literally a day-and-a-half trip to Chicago to find out that I almost blew myself up when I opened the door because so much sewer gas has accumulated. And when you have $2,000 worth of electricity running per month, that's a lot of open hardware that's just sitting in the air, trapped in extremely explosive sewer gas. So if you don't want to kill yourself, be sure to monitor that very, very closely. I actually had, that's the local fire crew actually had to come and get all the piping cleared out because I couldn't get on the roof myself. So extremely dangerous, surprisingly. Every single aspect of this location was factored into our metrics. So we were able to build enough infrastructure that it paid for absolutely everything we did. So even though we had, you know, 2,200 USD per month in cost, we were able to pay off the electricity, pay off the internet access, pay off the other utilities. We disabled any non-essential utilities, blah, blah, blah. So we could basically dominate any network that we attached to because we didn't have to worry about the excess costs of the infrastructure overriding our profitability, which allowed me to be able to pretty much play with whatever I wanted, so within certain constraints, right? Because we didn't build an infrastructure that's as big as, say, the warehouses in China that have access to, you know, the Q&A pools for, say, NVIDIA or the other organizations that those guys contract out to, right? There are huge farms in China and Taiwan that are built solely on the technology they steal from these other companies that are being shifted in between organizations, right? So if NVIDIA says, all right, we're going to take 3,000 GPUs and ship them all out to be QA'd, if the company that's contracting says, all right, well, you know, 80% of these are actually okay, there's a point where they're kind of just sitting in slush, right, between the organizations, and nobody really knows quite where they are. And these massive warehouses in China would take advantage of that by saying, oh yeah, they're caught in shipping or they're being waited for like the final results of Q&A testing or whatever. And those companies would essentially like take a separate warehouse, take all of those GPUs, throw them into a massive GPU mining rig, and then mine the shit out of whatever altcoin they could that was profitable. And when we realized that that's who we were competing with, we were a little bit mind blown, like, really? These companies are contracting for tons of money, but they're actually willing to destroy these contracts and these relationships because they think this is a good idea. Like, it was just bizarre. So we weren't able to go on that scale. That's a completely different kind of scale. You're talking about competing with people that have thousands of GPUs in different warehouses all linked into the same cloud. That was crazy. Like, we're not going to do that stuff. That's stupid. Plus, they're getting their hardware for free, right? So it was a little bit different for us. And I decided that I was going to solve our problem by designing custom cloud infrastructure. So basically, I designed all the mining hardware myself. Again, I was really the only tech guy. The other guys are pretty much finance. So I put together the hardware, and then I designed very simple software that rode over secure channels, just managed all of these systems together in a way where I could say, all right, if I want to take, you know, 20 of our 50 GPU units, right, or 20 of our 50 servers, and dedicate them to just one coin at one time, I need to be able to do that in just a second's notice with one command instead of having to do it with every single server over and over and over. So again, by designing that stuff ourselves, it minimized our costs and allowed us to play with pretty much whatever we wanted. And it ended up giving us a whole lot of power in really bizarre ways. And that's what I want to talk about. Because the results of the power that we had created a situation where we're able to override things that we never would normally override as a regular user. Even if you have a fairly decent amount of hashing power, you're not going to be able to really abuse it in an interesting way unless you set up your own coin and then test with that coin, right? And that's a really slow iterative process. You don't want to waste time doing that. So I'm going to talk about the unexpected results, and that's pretty much going to be the bulk of the talk. The first thing I want to talk about is the team meeting in Chicago. Because the team meeting in Chicago is kind of where we decided, like, all right, things are really starting to come a little bit more and more into focus. We weren't really sure what was going to manifest from all this bizarre work we were going to do, but in the end, we realized that the result was all a lot of security-related faults. And not just the software, but the network, the infrastructure, also the exchange systems themselves, and any computers that are used to send messages back and forth between people that are paying for systems and people that are taking payments. It was completely retarded. Like, there was so much information. We ended up with a massive amount of data, and my friends actually thought, like, well, how can we monetize off of this? But turns out nobody really cares about security infrastructure except for, like, Coinbase. So if Bitcoin's going to change and grow as an actual usable financial platform, then, you know, that attitude has to change quite a bit. So let's start out with bullying the coins themselves, right? With the massive amount of infrastructure that we had relative to everybody else, we were able to do a lot of bullying. And this was the most fun part to me because it was easy, right? There are a lot of other things that we found that were interesting. Some of them are academic, some are not. Some things are very practical, some are not. But this was the most interesting thing to me because it was simple to do, and it was easy to create serious problems in coins that expected to have longevity, right? Dogecoin being one of them. And so I thought to myself, okay, well, if we have a certain type of infrastructure that will allow attacks, how do we pick a target, right? And the targets themselves are really fun because you have to find one that's vulnerable in as many situations as possible. And when you're talking about alternative coins, the first thought that probably comes to mind when you're thinking mining is bots, right? Bots number one and multi-pools number two, or a massive amount of people trying to take information or use information to identify which coin is going to be the most profitable, right? It's a ridiculous set of metrics that are involved in this. It's actually quite simplistic. But the end result is always going to be, if you have more hashing power than the most people that are on the network, whether or not your hashing power can dominate the network or not is really moot. The actual point is whether or not you can force the network to do things that you want to do just by joining the network, just by participating, just by doing something at the right time. So the idea is to find the time, right? Attacking the target is really, really cool. Okay, so this is a really basic thing, and you can actually still do this today. And it's still profitable today, oddly enough, even though most GPU-based mining is not profitable anymore because of difficulty and also because of electricity costs and ASICs being involved. This technique is actually still profitable. And the reason why is because you're basically attacking the things that the underlying coin is designed to use to target whether or not it's going to be able to solve a problem within a guaranteed amount of time, right? So if anybody here is familiar with coin networks, the number one thing that is associated with solving problems is the difficulty level, right? And you can change difficulty level or influence it in really interesting ways. The most obvious one is just by increasing hashing power, right? So attacking a target is really quite simple because you identify which blocks are going to be the most profitable, and you can do that by calculating based off the genesis block. And depending on what type of coin it is, they may or may not have implemented an algorithm to mask each one of those profitability metrics, but you can calculate it out. And you can say, for most coins, I know that the 10th block is going to be very profitable, the 11th block is going to be not profitable at all, and so on and so forth. There are certain changes that have been made to certain coins that can accommodate for that. Some use a random number. Others use a static number. I think Dogecoin switched to just a flat number. Point being, there are ways to solve that, but most people don't use those solutions. So what you can do is, again, just take the genesis block and calculate the probability that one of those blocks within a certain number is going to be profitable and the others aren't. When you know that number is going to be profitable, you just wait. Okay? And the number one thing that you can do is just simply join the network at the time when the profitability is going to occur. And you would think, okay, well, why just join the network? Well, again, I'm talking about the hashing power that I had. I'm not talking about the hashing power that somebody with 1 or 2 GPUs at home had. Me, as an organization in a warehouse in northern Michigan, I can take our 50 GPU rigs that have 5 GPUs each in them and point it directly at one coin at a certain time and completely change the entire way that the profitability scheme is going to be calculated, right? Because that's going to be a substantial change to their network. So the result number 1, identify a very small coin, right? And this could be any coin, cat coin. There was Nyan coin for a while. Nyan coin was really, really fun to abuse for multiple reasons. Also because the icon's great. But the best part is really just saying, okay, the difficulty is pretty standard. So it's mostly, if you have a standard difficulty, right, and it rises, difficulty rises when there are too many people, and then difficulty lowers when there aren't enough people, right? If difficulty is fairly stable, then you don't have a lot of bots, and you probably don't have a multipool in, which means that it's ripe for somebody like me to abuse. So I swoop in when I say, like, okay, the block I want to target is about 2 blocks away. So I want to get everybody pissed off about this coin, because I know that as soon as that profitability or that profitable block comes up, the multi-pools are going to swoop in, the bots are going to swoop in, and it's going to really suck for me. So what I do is I swoop in myself before all of the bots and multi-pools do. And I say, hey, all right, I'm going to jack this difficulty up to the point where they're no longer going to think that it's profitable. I'm changing the profitability ratio of the bots and forcing them to recalculate what they're going to do next. So they're going to retarget and prioritize some other coin and go off and do some other thing. So instead, I just wait. But I only have to do that for a certain period of time, because the most interesting point about this is difficulty is calculated at specific times. It's not calculated as a weighted system or a set of points over a period of time. It's just like, okay, it's been 10 minutes. At the 10-minute mark, what difficulty do I think should be retargeted? It takes about, a couple milliseconds for the software to analyze the network and identify what the next difficulty target should be. So all I have to do is calculate when that's going to occur, and then I swoop in on the network for just that timeline. I jack up the difficulty, but then I leave the network as soon as the difficulty is recalculated, because I don't want to waste my hashing power on a high difficulty, right? That's expense to me. That's creating expense, and that's where you're going to lose profitability. So I just said, okay, I create the high difficulty that I want to get everybody away from the coin, and then I immediately leave and go do something more profitable, right? So what occurs then, no bots join when the difficulty is going to change for the next block, because they presume that the same difficulty level is going to be there, high, right? And then I swoop in and do what I want. After spiking the difficulty, I completely toss the network upside down and just take my entire hashing power and throw it all at the entire blocks that I want right before the blocks change to the most profitable block. And again, that throws the bots off the trace. All of the bots think that they have something more profitable to do, and they go do something else. And then I immediately pull hashing power away again right before difficulty changes. When difficulty changes, now everybody's left. There's nobody left except for the core users. And the core users for an average coin is a handful of people. And these are all hobbyists that have little networks at home that could care less about multi-pools and mining or making money. It's because they believe in a coin, they believe in the architecture, they believe in the blockchain, whatever the hell they believe in, they've bought into something with this coin. They're not a threat to me, right? Because these are just a handful of hobbyist users. So now the difficulty is slumped to the point where it's completely abusable. The difficulty is now almost 0. Right? And there were a lot of cases, and Nyan coin was actually a really great example of this, and I wish I would have taken more metrics to show you. But the essential fact was that I could forcibly spike and then forcibly drop the hashing power to create a difficulty of almost 0, and then just take all of my hashing power at once and just massively attack the network. Right? So I am by far the strongest thing on the network at that point. I've already implemented a 51% attack because I've tricked all the bots to going and doing something else. The core set of users is sticking around, but they don't know what's going on because they're probably at work or doing something usable with their time. And I'm just completely dominating the network and getting as many coins as I wanted to. And if I wanted to implement a 51% attack, I could. There were a lot of situations where we could easily have done this and completely decimated coins for no reason, but we're not that much of a prick, right? So why bother with doing that? So we were able to do a lot of really, really interesting stuff with very little effort just by creating those simple calculations and looking at genesis blocks and seeing what networks could be attacked really easily. That was a really great way to create profitability. And again, this is still something that you can do today because most coins that are created have no idea what they're doing. They're doing it because they're scam artists or because they think that they're creating some kind of community, or they're solving some bizarre problem like Aurora Coin. Has anybody heard of Aurora Coin? Like one person? Aurora Coin was a coin that was invented just for Iceland. So if you live in Iceland, you're in a database by default. That database is public, so there's a record of every single individual that lives in Iceland. So they figured, okay, to create a profitable coin, we're gonna create this thing called Aurora Coin, and we're gonna pre-mine X number of coins for every individual that lives in Iceland. And we're gonna create a profitable coin just on that theory. Like you've got all these bizarre coins that have these stupid theories like that just don't work, right? So they have no idea what they're doing. And when you see that kind of model, it's really easy to abuse. And since most people are forking based on old versions of Scrypt or Bitcoin coins or Bitcoin clients, they end up with the same vulnerabilities that were patched like 6 months ago, right? So all this stuff is 100% still viable and you can still make money on it. It's bizarre. But the way that you solve this particular problem in the correct way is really with DigiShield, because DigiShield is this really great algorithm for retargeting like every 60 seconds or every few seconds, depending on how you want to tweak it, that reevaluates the network continuously. And it takes multiple points throughout the process to identify whether or not systems are leaving or joining the network en masse, which is great for multi-pool detection, great for people like me, identifying people that are going to abuse the system in this way. But a lot of people aren't implementing DigiShield. Dogecoin has, which, the Dogecoin developers, I'm going to talk about them a lot during this talk because they're awesome and they actually deserve a lot of respect because I've literally I've worked obviously with a lot of engineers and developers over the years. And these guys are one of the few teams that I've encountered that actually give a shit. And they work really hard to implement the most sound, long-lasting solutions as they can. So I have to give them a lot of credit because they were initially going to go with Komodo's gravity well, which is a horrible algorithm. It was a cute idea, but it's stupid. But they didn't. Instead, they went with DigiShield, which was the smartest move for securing the coin long-term. Komodo's gravity well was kind of a similar idea to DigiShield, except that it retargeted in a longer period of time. It also didn't take into account asymmetric ability to identify whether or not targets were joining en masse, right? So Komodo's gravity well is only usable if you have a coin that's really meant to have a small user pool and doesn't have an algorithm that a multi-pool can actually cash in on, which is rare these days, right? So KGW just really doesn't have any value anymore, and significant hashing power, you can attack those blocks as well. In fact, some of the coins that I attacked with just en masse brute force hashing power were on Komodo's gravity well, and it didn't matter because I could still implement the exact same attacks. It's just a smaller window than what the default window would be. DigiShield is the correct solution for this problem where it retargets every few seconds and reevaluates the network en masse. So bullying clients themselves is also really amusing to me. And this was the thing that I wanted to talk about the most during this talk, because this is where Dell beat me out. So back in about February, we started this again like late December, early January. We were starting to identify odd behavior in the coin networks. And we were all trying to figure out why. Because attacking the wallets themselves doesn't really do anything. The wallet software isn't 100% proof, as I'll actually talk about in a minute. But generally, the wallet security theory is sound. So there isn't a lot you can do to abuse the wallets, but we kept seeing this weird traffic on the network. And especially when you're running 50 different mining systems and you're targeting all these different pools, we didn't use the multi-pools because we knew better, right? Because when you have that large enough of an operation, you can be the multi-pool, you can do whatever you want, so why pay somebody else those shares when you can do it yourself? It doesn't make fiscal sense. So it's irresponsible to use the multi-pool, and instead you are your own multi-pool. So what we would do is watch the behavior of the multi-pool to see what it was doing and identify ways that we could increase profitability by mimicking what they were doing, but not paying their cost, right? Not paying for them to make the decisions. And we were noticing that there was a lot of strange things going on. They were starting to make decisions that didn't have a profitable result. And this started happening around February. And we kept asking ourselves, why? And we couldn't come up with a valid reason. And I actually started to ignore it. And I started to say, like, okay, well, either this is an anomaly or they're starting to scam their users. I can't tell which one it is, so I'm going to set all these metrics aside because they don't make sense to me. So after about mid-February, we started just kind of blowing them off, saying like, okay, this is no longer interesting at all. What ended up happening, we ended up identifying that some of our routes were changing, oddly. And I was doing that because I was using TCP sniffers, right? And one of the great things about TCP is if you're familiar with the trace route, a trace route is based in UDP, right? But a trace route in UDP, it's, you've got to re-crawl through the entire stack every time that you want to update the route. But with TCP, it's a lot more interesting. With opening a SYN connection, right, getting the three-way handshake and creating that established connection, you can create using promiscuous packets, right? Using raw packets and an established TCP connection, you can essentially simulate the same thing as a UDP trace route in TCP. So you can watch every single iteration of the packet traversing from one IP to its peer and identify whether or not the route has changed. Sometimes it will just because of normal behavior, but we identified that the connections that we had to some of the pools that we were using were being hijacked. And we were watching the ASN change, the destination ASN change, and the destination ASN would change from like Brazil to Canada, or like Japan to Canada. And we kept thinking like, okay, well this is bizarre. And we were looking at some of the forum posts from the people that were using the multi-pools. And all of them they weren't observing the same detailed data as we were, but they were observing the same behavior. The result is suddenly my IPs are changing to this place where it shouldn't be going, and we don't have a reason for it, and there are no records, and this IP isn't associated with the multi-pool. They were all talking in the context of the multi-pool, so we were thinking it was a multi-pool problem. But when I started seeing it happening with our software, then I knew that it was a network problem. So the obvious thing is to start looking at the ASNs, right, and seeing what the ASN routes are actually broadcasting. Because if you're seeing an ASN change from one country to a completely different country, you know that there's something seriously wrong with that if it's not a cloud provider, right? So we were able to identify that somebody was stealing money by basically hijacking the routes between a client and the mining pool. What they were essentially doing is just using a standard BGP attack, right? Just announcing a route to really popular pools or multi-pools, and then redirecting all of the traffic to an ASN that they owned. So what was occurring was they had just hacked some service provider in Canada. And what they were doing was abusing a router there to perform the announcements, and then they configured a server to mask as a legitimate multi-pool or several legitimate multi-pools. And then whenever the traffic went to that pool, because they knew they can't keep the link up very long, right? So when you're hijacking BGP, if anybody has experience doing that, you usually don't do it for a long period of time because you get noticed very quickly, right? So if you do it for too long, then people are going to find you out. But if you do it in little spikes here and there, like short heartbeats, wait for a while, okay, do it, wait for a while, okay, do it. The goal is to reroute everybody's traffic by rerouting traffic, and that's exactly what these guys did. So because there's no SSL in mining software, what they were able to do is send a message as a fake mining pool server saying, hey, you should reconnect to these servers over here, which is a standard allowed message within the context of mining software. So these mining software would receive the message and say like, oh, hey, I'm supposed to reconnect to this server over here. That's actually really common within small clusters of pools. So it's not an abnormal command. It's a totally normal command to use within the context of mining. But it shouldn't be used because they figured out the way to abuse it. Let's do again. Hijack the route, pretend to be the actual mining server, and then send the message saying, no, 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 no. Reconnect to this other IP over here, and that other IP is going to be the actual evil host. So you can see the regular theory, like this is the regular network that you would see in any environment, any client-server environment. This is what it's going to look like, right? Some PC, some workstation, hitting an application somewhere through the cloud or the internet, right? The model that you're looking at in the attack is in red above at the top. You've got the evil router performing the announcement, and all of the clients are deciding that they're going to go to the fake mining pool, right, up in the top right. So the red routes identify the routes that have been hijacked. They're all going to the fake mining pool, and the fake mining pool is say, no, 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 here's a message that says go to the evil mining pool, because my link isn't going to stay up for very long. The evil mining pool's actual IP address is used in the message, right? So what ends up occurring is now the attacker's cashed in because he's pointed all of the mining clients to the evil mining pool. The evil mining pool is actually issuing real work to these clients, saying, I want you to do this, I want you to do that, blah, 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 blah. Solve these problems for me. When the solutions go to the evil mining pool submits the calculations to the network, but then never gives out the reward to the people that actually found the blocks. And by doing that, they were able to steal about $84,000 within the period of 2.5 months. So if they would have been able to carry on with this attack, it would have had substantial gains, except that this was too loud of an attack. What would have been better and much smarter is if they would have shaved money off of each transaction. So if they would have actually hijacked the routes, performed the calculations with the clients that they hijacked, and then doled out short rewards, anybody that's getting a reward in these kinds of environments is not going to care. They're going to say, oh, I'm making money. Fine. But if you're shaving a little bit of money off of each transaction, like in a typical, what do you call it, sausage attack, right? Nobody's going to notice. They could have been doing this for a year easily and made far more money than $84,000. I mean, $84,000 isn't that bad, but in the context of hijacking, like this whole setup, right? Taking the time to crack into a network, taking the time to do the actual BGP route attack, taking the time to figure out how to set up the evil mining pool, simulate all this crap, all this time that it took to set up the logistics for $84,000, this was a waste. If it was me, I would have been sucking way more money out of this attack than $84,000. I'm sorry, but that was a really shitty way to implement this attack. So to whoever did this, you suck. Because you really fucked up. You really should have gotten way more money out of this than you did, and I feel bad for you. So you were probably 12, and good for you for being 12 and figuring out how to hijack BGP. Good for you, but you really wasted time. So there were a lot of things in the Bitcoin and Dogecoin, et cetera, coin technologies that enable this attack. Number one, everything's in the clear, right? Because they're trying to save time. All the messages are meant to be very, very lightweight. So essentially, all the messages are clear, and it's just simple JSON text, so you can inject whatever the hell you want. And if there are redirects, then it's game over, right? So what's really interesting about this is that SSL can be used by pools, but SSL usually never is. And even if it is, it doesn't matter because it's not going to be authenticated correctly. The mining software doesn't authenticate things correctly. And most of the pools use IP addresses, so it doesn't really matter whether they do or don't. In fact, this is the source code for CG Miner, which is by far the most popular mining software for any coin. And you can see in the highlighted line, the option is to use SSL, but it's to try, right? So if SSL doesn't work, it's going to fall back to non-SSL. There's no error that occurs because they set up the curl library to not care. So it's not going to send you a message. It's not going to say, oh, there's been a problem. It's going to tell you, guess what? We tried to use SSL, but it didn't work, so whatever, right? There's a more important thing that I did not highlight in this that's a couple lines up. You see curl opt underscore follow location? It's set to 1. That's set to 0 by default. Can anybody tell me why that's familiar with libcurl? Anyone? It's really obvious even if you don't know libcurl because of the name of the option. Follow location, right? So this is usually used when you have an HTTP 3XX code. HTTP 3XX, what does that do? It just says, hey, guess what? I want you to go to this other IP address. So even though the solution to this is to just alter the software to not allow redirects, it's still vulnerable to this exact same attack today, right now, because libcurl is configured to listen to follow location. And because SSL is set to fail, even if somebody sets up SSL correctly, it's going to fail if you point it at my IP and I tell libcurl, like, oh, sorry, SSL is not enabled here. So it's going to fail SSL quietly, and then number 2, it's going to follow the location that I tell it. So I can set up the exact same attack even if the RPC protocol is no longer enabled to allow that redirection command to occur, which in the latest software is exactly what happens. The latest software disables that redirect command, but it does nothing to that libcurl stuff. So the libcurl location follow can be forced. So I can implement the exact same BGP attack today, but just issue the location through HTTP 3XX command and still be golden. It's going to absolutely do 100% the same thing. So this attack is 100% still usable, right? And if they don't solve it, I'm going to go do it myself for way more than 84 grand. But that would be stealing, so just kidding. So that's, I mean, that's a really, I think, a clear demonstration that, not only are the environments themselves insecure, but the software itself, I mean, the implementation of the protocol is great, right? The wallet protocol is excellent. The actual Bitcoin design is great. The enhancements that they've added to Bitcoin to secure it have been excellent, right? I'm a big fan of Dogecoin, like I've said a couple of times already. But when you have implementation commands such like this that are breaking the integrity of the entire network, it's very difficult to put a lot of faith in this kind of architecture as a financial platform, right? Sure, we can solve bugs, but we obviously have a really long way to go before we can use this in an environment that we trust, right? I mean, we have very similar problems with NFC, et cetera, but I mean, you're kind of seeing where I'm going with this. This is all very, sad. So from the server perspective, I don't even want to bother with that because I don't have much time left, and it's all PHP. So if that gives you any idea of what I think about the security, that's really all that needs to be said. So let's move on with the coin software itself, because the coin software is really cool, right? The wallets themselves are designed really well. They're not exceptional, but they're not riddled with software bugs. I mean, there are a few flaws here and there, but it's very difficult to exploit it, and most of the binaries are compiled correctly, as in, they're supposed to be using ASLR. They're supposed to be using, dynamic executables instead of standard static executables. So they run in a safe environment from what we would normally think of a simple application that's running in user land, like a third-party application. But the issue is that there are so many changes in the protocols and so many enhancements that have been used to secure these technologies that if a new coin comes out with a really excellent idea, in fact, is the guy here that was telling me about IDS in Bitcoin IDS fused together? Because that was actually pretty cool. Is he here? No? Okay, I think he's one of the 44Con guys, so he's probably working some other room. But the cool thing about this technology that this guy mentioned is that they're using Bitcoin as a way to detect intrusions, right? So they can kind of use wallets as a way to say like, oh, we identified whether or not an attacker has compromised this location because we can see that the Bitcoin addresses associated with this location have transferred Bitcoin to another location. You keep a very small amount in your Bitcoin wallet, and that, the cost that you lose is far less important or far less valuable than the knowledge of actually having known that an intruder was there. Right? So the infrastructure is really interesting, and we can rely a lot on the wallet technology because of the safety and security that's designed into the wallet. Like, we can trust enough to build IDS and IPS on that software because the software is refined enough. Right? So, the software itself is pretty good. The problem, again, is that everybody used the exact same code base. And there are a couple of problems with that, not just in the evolution of the technology, but also that people are adding and removing things that they shouldn't be. Right? The subtle changes are where things get really, really interesting. The DigiShield software implementation was only a couple hundred lines of code. So if you look at the changes of wallet software over time and across different alternative coins, you can really see unnecessary code changes all over the place. You'll see where they shift from C to C++. You'll see where they shift from C++ to some other variant language. And it really is kind of ridiculous when they don't need to make these changes at all. It's just one guy is more familiar with one language than another. But in introducing C++ to the mix, he's incorporating vulnerabilities into the C++ code because he's trying to port stuff over from C, and he doesn't quite get how to port it correctly. But there's a lot of that going on. Right? So even in most cases, you're going to see fairly refined software. It's actually quite dangerous to just use random wallets. The old code is obviously still an issue. And one thing I really want to point out is if you're interested in this technology or abusing it, or even just compromising it for no reason, finding coins that have IRC enabled is really interesting, especially ones that are using IRC but have IRC binaries distributed and nothing else. There are a couple of scam coins out there that are widely distributed for whatever reason. These guys get market hype. I don't even know how. But people download the stuff because I guess they're hoping to hit the lotto. But they end up with this wallet sitting on their computer that's just a compiled binary that's essentially like, I don't know if you guys are familiar with this, but one of the initial ways that the peer-to-peer protocol in Bitcoin identified its address and found peers was it connected to an IRC server. And then it reached out and said, who else is on this IRC server? Okay, what's your public address? Well, I'm going to connect to you, and I'm going to try to identify, like NAT negotiation, all this other stuff, because I want to create a meshless, peer-to-peer, right? The problem with that is that the IRC software is no longer in Dogecoin, Litecoin, Bitcoin, etc. So if you see any new coins start to pop up that have IRC still enabled, and you can connect to those IRC servers and actually see the coins, right? Because the names of the channels that are just on the IRC servers are all named after the coin. So you can see like, pound Yan coin 1, pound Yan coin 2, and you can see all of the clients that are connected and joining that coin. So you know what IP addresses are using what coin, what versions of the software are used at that particular IP address. If it's an old version of the wallet, then you know that person probably doesn't care about the wallet. But then it begs the question, do they care about updating other pieces of software on that particular system? Maybe, maybe not, right? But now you have IP addresses like any P2P network, whether you're using DNS or IRC or whatever. It's just very easy to write an IRC bot to connect to that system every few minutes and gather all the addresses per coin that you want to see, put it into a database, and now you can say, all right, attack all these addresses because I know there are wallets there, right? It's a really simple thing to do. And there are other ways of getting peer addresses, obviously, because you have to have a peer-to-peer protocol in order to find other people on the network. But when there are so many people out there that understand how to use or reuse IRC bot code to gather information like that, It's a really great way for people with a very small amount of skill to enable a massive attack against people that are known to have monetary systems on their computers, right? So any new coin that's being released that has that technology enabled is immediately suspect, because there's no reason why that technology should be enabled at all, and it's disabled on any coin that actually gives a shit about security, or just being, an up-to-date coin, like having up-to-date technology. So that's a really, really big problem. Also, I caught one guy, I want to say it was March, trying to backdoor a coin. They changed some code on the GitHub that I thought was interesting, because they didn't add an RPC command, but they added a variant of the IRC channel that had a very, very subtle buffer overflow. And I kept thinking to myself, that's funny. Why would this code do that? They were basically trying to implement a backdoor in the IRC code. So when that coin updated, every single client that updated their wallet would be compromisable over this simple IRC buffer overflow. It was actually quite brilliant, and it was slick if he would have gotten away with it, but he did not. So sad for him. Also, I just want to point out very quickly that there are a lot of coins out there without a plan, and those coins are awesome to attack. So Defcoin is one of them. The Defcoin community is fun. Like, it's just 303 guys from Denver. They're just good guys. But they put together a coin for DEF CON for no reason other than they just wanted one, but they didn't implement anything, any strategy, any security strategy, any business strategy, no strategy whatsoever. It was basically like, we're gonna get fucked up and tell people this coin is awesome, is their strategy, basically. So what's great about identifying these coins, though, is that they're brilliant ways to exercise your auditing skills. Because most of this technology is implemented by people that don't know what the hell they're doing. And I'm sorry to say that the Defcoin guys do not know what the hell they're doing. So auditing the code that they've published, not only in publishing the variant of their wallet coin or their wallet software, but the pool that they're using to implement the networks that they're building up is also quite interesting as well. So if you want a couple of small projects just to get involved in coin technology to see why it's vulnerable and see what can be done with it, check out coins like this and then compare them to the more versatile coins and the more refined coins like Dogecoin, et cetera. You'll really start to see a huge gap in technology, not only in technology, but in just security. And you'll understand why so many systems are out there completely vulnerable. I briefly want to talk about the exchange issue because I'm working with the Dogecoin team. Trusting trust is a big issue in exchanges, right? Because when you need to actually sell off coins, or you want to create a payment system, or you want to actually let people buy things, or use this technology for what it's supposed to be used instead of just like pretending it's money, is a really big deal because nobody's really doing it correctly. I think Coinbase is the only organization that I really trust, and even Coinbase has a lot of flaws. They gave me, I don't even remember how much money, like $2,000 or something like that, for finding a flaw in their code. Their code's not awesome. It's got bugs, but it's the process that matters. And that's really what is concerning here, right? Because everybody has bugs. Bitcoin's got bugs, Dogecoin has bugs, Coinbase has bugs, the software I write has bugs. What matters is whether or not you have the process and infrastructure in place to identify those weaknesses and resolve them in a reasonable amount of time, right? That's the most important thing that can occur in any system, not just financial-based system, but any system. So if you take the time to identify the organizations that have gone through these issues and resolved them, you'll find very few, right? And those are going to be Coinbase. Cripple is actually not that bad. They used to be not so great. They're better today. I think Kraken cares a lot about security, but I don't have a lot of experience with them, so I know they care. I can't speak to how much they care. Dogecoin, I keep bringing them up. Again, Dogecoin's awesome. Don't discount them. But when you look at the overall ecosystem, it's actually quite lacking because most people are just trying to get into the bubble. And when the bubble bursts, we're going to end up with a lot of technology that doesn't have the robustness or longevity that was expected to have. And that's not where a financial platform should be, right? So we're in a very infantile state. So what I'd like to do is introduce the Dogecoin security standard, which is kind of a thing that I initiated with Arnicles from Dogecoin. It was really his idea, but I decided to put together a standard instead of just kind of write an outline of what things should be used. And the goal for this is to identify the right way to implement an exchange or the right way to implement a business within the Dogecoin system. And we also have experience with that because earlier this year at Hack in the Box Hackspo, I demonstrated a technology that I invented and my partner Max invented called Dogeflame. And the idea behind that is using community-based donations, but via SMS. So you can send somebody Dogecoin just by texting it to them. It's very simple, but the great idea behind it is that you can support an entire community by texting a community money, right? So if I want to support the community that I came from, which is Flint, Michigan, that's where I grew up, it's a struggling community. Say I want to support a farmer's market there. I can just text money to the farmer's market, and now I've donated money that people in the community can use to buy goods and services at the farmer's market. It's a cool idea, but it takes a lot of infrastructure to make it safe. So what we learned about was the process of implementing and deploying safe technology that can be integrated into Dogecoin, Bitcoin, or whatever. It's difficult to do, but you can do it with some very simple rules. You know, just managing transactions is a big deal. But people have been doing really stupid things in Bitcoin and Dogecoin environments. And a really good example of that, I think Vercurex and a couple other, I want to say BTCE got hit at one point as well. But a lot of these exchanges are putting their hot wallets on the same environment that they have their web infrastructure. And these guys don't really know what they're doing from a web point of view. So if they have some kind of a web-based security fault, you can just land a shell on that server and you're staring at the wallet address, right? So you can just ship all the coins that you want to somewhere else and you're good. They have no idea what they're doing. So separating the duties of these different types of technologies is imperative. Evaluating the software is also something we're going to talk about in the DSS. And this is just simple basic stuff. I don't want to recreate what's already been done, but I want to be able to point people to appropriate ways and appropriate documentation on how to set up these simple concepts, these concepts that are very standard and simple to us. They're not standard and simple to other people, especially in budding environments, budding ecosystems. So we're going to create that and make it easy for people to understand. Architecture, again, is extremely important as well. And not just putting your hot and cold wallets in a different environment from your web infrastructure, but also isolating information and prioritizing assets and classifying what data is going where. It sounds like it might be a big deal to people, especially people that aren't security analysts, but it really doesn't take that long. And once you start out with an appropriate threat model and you have a way of classifying data and classifying how that data is going to flow in and out of certain areas, you're going to have a much easier time of implementing your system and changing your system, improving your system, and monitoring your system over the lifetime of that environment. So we'll be discussing that as well. So the overall problems that we've identified is that absolutely nothing in any of these architectures is refined today except for the wallets, right? Dogecoin, again, is probably my #1 coin just because I work directly with the Dogecoin developers and I listen to their concerns. And they have a lot of concerns and they're addressing them actively. No other community besides Bitcoin has that kind of standard, in my opinion, right? You'll see some of that in Litecoin, some of that in Ripple, some of that in a couple other top tiers, but not in the way that Bitcoin and Dogecoin go back and forth on how things should be implemented, whether things should be implemented securely, whether the security solution is going to impact negatively the client aspect or the server aspect or the peer-to-peer aspect. You're not going to see that level of depth in a lot of the organizations that are out there today. Again, Coinbase is one of the few. So as we see this market mature, if it can, right? Who knows how much longer it'll be around. Hopefully it's around a lot longer, because I don't know if you guys saw this, but IBM is actually interested in using Bitcoin-based technology and even Dogecoin, the blockchain technology, as a way to secure and implement the Internet of Things. So that'll be really interesting if we can see this technology grow and extend itself long enough for that to become a reality. But overall, you've really got a ton of different options out there, and they're all very cartoonish, right? It's all just random piles of code copied from somebody else, and re-implemented as the next standard, secure, private, anonymous financial platform. It's bullshit, right? But it's interesting bullshit. And hopefully we can turn that interesting bullshit into realistic bullshit. So it'll still be bullshit, but it might be usable at some point in the future if we can identify the weaknesses in the infrastructure and do something more elegant with it. Solve those problems with actual tangible technology, right? And today it's not there, but maybe it will be in the near future. So there are a lot of ways to attack today: BGP, route messaging, just standard buffer overflows, PHP. I should never associate those two things together. But overall, we've got a long way to go, but at least we're starting out with one solid base platform that has a little bit of security robustness. We'll get there in the rest. Thank you.